Good afternoon, good morning, and good evening. Welcome to EIG's 29th webinar in a series, and this is our 29th webinar on finding a resilient and building a resilient enterprise. Today we have with us Fuse Machines and Data Speckle, and we appreciate you taking the time to join us in light of the coronavirus pandemic, and we hope that your family are healthy and safe. This is the third of a series of webinars on bringing practical artificial intelligence solutions to your business. The first webinar focused on optical character recognition and intelligent character recognition, and we focused on developing the how-to 3 steps to build out that transparency of that data. The second webinar, Image to Insight, focused on deep learning and computer vision, focusing on the images, and we did a case study with the Altman Z-score. This webinar today will be on Video to Insight of human behavior, and we'll focus again on deep learning, but also computer vision, with a case study on and getting into safety as one of the major areas. We look forward to an interactive webinar and participation in the polling. And we look forward to your feedback as we move along. And my name again is Jim DeVries. I am president of Enhance International Group. We're a platform of providers that provide everything from consulting to SaaS solutions. We again focus on expanding and sustaining your organization's resilient enterprise. Our goal is to provide collaborative, collective, experienced thought leadership to enable your organizations to thrive where others may not. We want to give you that extra edge, that competitive advantage. Again, we hope that you find this information valuable. We'll be sending out the slides, and we want to answer as many questions as possible. So feel free to ask questions at any time within the chat window, and we'll get to them as best we can. Just a little background: EIG focuses on people, process, data, and technology. We've done quite a number of webinars. Our next webinar will be on supply chain risk and resiliency. We also have an upcoming webinar on digital twins. And we also have some webinars on hyper automation and also getting into simplifying Lean Six Sigma deployments with operational excellence tools. So today we have with us 2 esteemed guests with us, Dr. Bulent Unica and Carol or C. Bonovich. So, Doctor, will you start and provide a little introduction to kick us off?
Thank you very much, Jim. Thank you. First of all, thank you for all of you just attending this, taking the time. I hope this will be an entertaining webinar as much as we enjoyed preparing it for you. So my name is Bulent Unica. I'm a physicist. I have worked almost at every wavelength possible for imaging applications, automation, sensors, radio antenna, interferometers, satellite data. I had the opportunity to teach at the University of British Columbia medical imaging computer vision courses. At the same time, I was privileged to help BC Cancer Agency for flat field mammography detection algorithms. We are running at Data Speckle, some sort of a very small boutique AI company. We are trying to use the scientific method and the best tools available for the problem. Thank you very much.
Thank you, Bulent. Carol, C?
Sure. Hi, I go by C or Carol. I always say to people, I wanted a new name for the new century. Anyhow, I've been at Fuse Machines. It'll be 6 years in May, so that's pretty soon. And prior to that, my career was in finance. Fuse Machines is an AI company. We focus on AI talent, AI consulting, and AI education. So all things AI. And we work with Boulant and his team regularly to solve some significant AI challenges that enterprises are having daily. So I think that's enough of my background, and I'll give it back to Jim.
Great. Thank you for that great introduction. So with that, again, just a reminder for the polling to please log in to polleverywhere.com. In the chat window, it has a link. And with that, C will kick us off.
Sure. Whoops. So just to review, Jim actually went through most of it. This is a practical AI series, and our first one was on OCR, and we covered the basics there. And as I say to people, OCR is really your first step usually in a digital transformation. People have lots of paper, they've been saving for years, and we want people to get the most out of all these documents. That was webinar 1. Webinar 2 was Image to Insight, where we dealt with both deep learning and computer vision. And we discussed the Altman Z-score, which is a way to identifying if a company is healthy financially. So if you're going to do business with a new company as a vendor, you might want to know what their Z-score is. Both of these are available through the EIG website if you want to see a link to these former events. And today we're going to do part 3, and there is going to be part 4 and part 5. So we hope you'll continue to join us. And today it's going to be Video to Insight. And we're, as Jim said, we're going to be talking about, once again, how video can be used in your AI journey. And what is the next slide? Webinar 4 will be a continuation of the things we don't get to today, because there's an awful lot to talk about. Okay. Is there a next slide, Jim?
Yeah, can you see it?
Yeah. Well, we just sort of covered that already.
Oh, this is the agenda.
Yeah, okay. So now we're going through what today's agenda is. We're going to review a little bit about what we taught people in webinar 1 and webinar 2. We will cover object detection and pattern recognition. We'll also be discussing extracting information within video. And then we will talk about our ADA framework. It's a framework that we use to help people understand if they have an AI-ready challenge. Many of us have lots of good problems to solve, but not all of them are going to be practically solved with AI. And then we will also talk about our safety case study. And safety is something that all businesses have to deal with, from hospitals to manufacturing plants to you name it. Businesses are dealing with safety day in and day out. Next. And then we'll do questions and answers. But feel free to put the questions in the chat. When I see them, I'll look at them and I'll see if it's a question for Boulant or for Jim, and we'll answer them along the way. So we don't have to wait till the end. Okay.
Great.
Yeah.
Thanks, C. With that, we'll just get started and a recap of image to insight data transformation. This is the general workflow for document automation. Data can come from, as we know, many different sources: images, photos, PDF files, and even an image, a still image out of a video. And a lot of this data is stored sometimes in ERPs and sometimes streamed sources such as internal or external social media. Our overall goal, of course, is to transform this media into ones and zeros. That's our goals. And it's all about the ones and zeros. And data can come through a few different formats. So the first approach is when the data is already in ones and zeros. And if the data is already in ones and zeros, you're in good shape. And that's often, we see that in emails, websites, converted documents, and this data is freely accessible. So we're getting to a world where more and more of our data is being created in these environments, and then that makes it quite easy for us. But however, in the world that we live in, to get to these ones and zeros, we often have data in other forms So the second approach is converting those data from these type of images, and this is the beginning of the OCR or intelligent character recognition. And this is obviously the most mature area of the conversion approaches. The characters can be embedded and typed or written documents, and then converted into ones and zeros. So there's some very good algorithms out there, fairly mature. The third area is where probably in the last 10 years, you've seen quite a bit of work, and that is the situation where you're using pattern recognition and probabilistic modeling when the data that exists is in degraded pages. It may be smudged, it may be smeared, it may be blurred. And there we're going to use some higher level sophistication. And then the fourth area that we covered in the previous webinars is finding the needle in the haystack. So very often we're looking for a particular table or a particular image in a large document. It could be a 1,000-page document, or it could be a library of books. And again, we're converting all this so that we can do that data mining, cleansing, process mining that we all hear about to make intelligent decisions and help us in our journey there. So again, this is the transformation that we had discussed before. So as we move to the 2021 computer vision application trends, if we look at from Kaggle, where the predominant areas are, safety comes out clearly as number one, whether it's public or private, or it's in a company, or in any kind of environment. That it could be your home. All those is where we're seeing the predominance. Then there's also the quality detectors, and that started in the semiconductors back in the 70s and 80s and has grown. And then you have thermal imaging analysis and many other types of applications, real-time applications for edge computing, and so on. So we will get into more of these as we go along, but these are the trends that we're seeing overall in the industry. So there's quite a bit of opportunity out there to use this computer vision technology. So if you look at the industry as a whole, the trends from in data labs, you can see that the consumer industry in the e-commerce area is clearly leading the charge as far as the market in millions of being focused. So you can see in 2019 that the millions of dollars spent there, in that overall escalation in the market. So that market is clearly growing. We're also seeing the robotics, process automation and robotics, physical robotics, machine vision, that's growing quite a bit. And then the automotive, of course, with the autonomous cars, that market's only going to grow faster in the future. Of course, the security and surveillance has been doing this type of stuff for the last 20 plus years, but because of many reasons, it's not moving as fast as the other areas, and of course, sports and entertainment. So that gives you a little bit of background on where we're seeing the growth in computer vision. And with that, I turn it over to Bulat.
Thank you very much, Jim. Very nice introduction. So lots of things about machine learning, artificial intelligence, computer vision, all these hyped sectors actually. I think it makes sense to start with the definition, or at least what we understand when we say artificial intelligence. Everyone probably has an idea already, but as a refresher, in a conventional way of thinking, we have a set of rules and data. When we have data measuring some certain quantity, we simply enter that data into the set of rules and we find the results. It's very useful, which is the conventional way, the functional way of computing things. You have data, you have 5, and your set of rules says that you need to take the square of that number, whatever enters into your function, so to say, and we simply square that number. The function, whenever it just sees a number, it just multiplies or just takes the square of that value, and we got the result. So when we like to make the definition of artificial intelligence, I find there are so many different definitions probably, but I find this definition very useful. Artificial intelligence is a collection of methods that is mimicking the way humans are thinking. And in that, we are not relying on the conventional way of set of rules and the data. We start actually from the data and the results. When we start, we actually know that our data is 5 and the square of that number is 25. We already know the answer, and we are asking the machines to understand the complex and grift association between the data and the result. So the collection of all these algorithms, all these programs and everything that is trying to find the association between the data and result we call as artificial intelligence methods. So I would like to interpret this slide over here from right to left. Artificial intelligence is at the top, and underneath, under that umbrella, we have machine learning, robotics, natural language processing, and planning, obviously scheduling optimization, and speech. Of course, data comes in voice and vision, and expert systems are just fuzzy logic. And in the absence of many experts, actually, we can collect the opinion of experts on some certain common problem, and we can make an algorithm operate like an expert and find a general consensus of many experts. So under all these subgroups, we see deep learning, predictive analysis. We just come across a lot of time, especially in business, in the form of time series and demand forecasting. When we just go for natural language processing, which is a very huge area in artificial intelligence, we come across translating tags, classification, clustering, and obviously information extraction from the documents that comes from emails, documents, PDFs, OCR, all these things that we can count. Speech obviously is very important. That is being used in many areas that include medicine and many other different areas. The idea here is there's voice and how we can actually convert the phonemes actually in any language. If you simply remember, there are only 44 different sounds as building blocks of English, and with those 44 sounds, we can create any word we want in English. So the idea here is, can we convert them into text and vice versa? And obviously vision, because information, the wealth of information coming from the visual sensors is enormous, and we would like to recognize the images, we would like to classify, and we would like to teach the machines to see the images, the environment as we do see and as we interpret. When we just move forward, we will see different applications of computer vision and such. And today, we are going to be mostly concentrating on the computer vision cases, as we have discussed the other 2 cases in our previous webinars. So here is an image. On the left-hand side, we see a person and a face, and that image comes with a lot of connotations. You can think about history, you can think about the person, you can think about the fashion if you like, if you look at the hairstyle, if you look at the clothes and everything. All these informations are carried to us because we have this some sort of the so-called semantic understanding of an image, because we understand all these associated features and things with the image itself. It's not only an image, it's not only a face. For a computer, however, there is semantic gap, very famously known, because computer sees these images in a totally different way. for a computer, this face is not a person. It's just a bunch of numbers ordered in a matrix. As we see on the right-hand side, probably the right-hand side image is the best representation of what a computer sees when we simply present an image. And obviously the rest is making sense of those numbers, those bunch of numbers we sometimes call matrices or tensors, into information and then visit them afterwards. Moving forward, when we have this image, we can actually do a lot of things with these images. We can simply look at these images and we see some blob of ink concentrated in some particular area of that image. And we try to understand that, and the best application of that is to figure out the image, to figure out the objects and distinctly from the background. There we see a lot of masking applications. These masking or segmentation applications are actually the basis of medical imaging and many other applications that we see in space imaging as well. Background subtraction and isolating the objects is one of the prime concerns all the time, because the images may not be as simple as we do see here in this example. But this is very well-known segmentation problem. Moving forward, we do have several other applications. And when we simply look at the images, we do not always segment the images, but we would like to figure out what is happening in that image. If we look at this image from left to right, we have an input image that is a person wearing a mask, for instance. And we go over little chunks on that image using a sliding window technique. You can see a very small rectangle on that image. For this little small rectangle, we apply a filtering, the so-called convolution map multiplication on that image. And every time, depending on the size of that filter we apply, we get smaller and smaller and smaller versions of those images. So consider that on the left-hand side, we have hundreds of images, people wearing masks or not. This is just an example. Obviously, it could be any image on the left-hand side. We simply go through each individual image through a sliding window. We simply convolve, and at each step, we simply create a hierarchical information extraction. That feature extraction step, usually called, when we simply put all of them together, as a convolutional neural network, mimicking the synapses in our brain, obviously millions of those. And afterwards, we simply stack them all together in one single layer before a classification layer. And in that classification layer, we simply go for a multinomial probabilistic calculation based on the activation functions and the stimulation of those so-called artificial neurons. And we determine as a probabilistic value whether that image entered is belonging to some certain class or not. On the right-hand side, we see that one image at the top is 90% a person wearing a mask, whereas it is 10% wearing a mask on the right-hand side. So this is basically called the artificial intelligence basis of neural network calculations. So in short, CNNs. That is usually used for many purposes, but mainly this classification idea usually comes at the end. Moving forward, we do see so many different examples of this. Here is an example of that sliding window I was just mentioning. It just simply goes through, traversing through the image and finding the object of interest and extracting all this information. At every step, we are applying these convolutional filters on that particular image. Obviously, we are not only tackling with one certain image, we are tackling with thousands of images. Moving forward, we will just see some examples of computer vision, deep learning, and business applications, obviously, that are using these techniques.
Great, Bulent. Thank you. So we have our first polling question coming up. Again, if you would join us in this poll EV ranking question. So if you're on your browser, on your computer, you will be asked to rank these, and there's quite a few of them. So if you try to do it on your phone, it may be difficult. So we apologize for that. But if you have another screen open, it really helps. So with that, we'll go to this polling question to rank your top 3 or 6. You can rank them all, but maybe just choose the top 3 to 4 most useful control vision applications for your business. Could it be security, safety, transactional, maybe consumer purchasing, manufacturing quality, control monitoring? Which of these come out as far as a priority for you and your company? Or there's something other than what's listed there. If there's something other, please go ahead and put it in the chat window. We'd love to get your feedback. Just trying to get a sense of the audience of which of these are of particular interest to you in your company. So you in the poll EV, you'll just be going in there and ranking those top 2 to 3, maybe 4 in that list. So hopefully that works for you. Boulat, from your experience, which of these are you seeing the most applications? Boulat and C.
Automation, I think the automotive sector, medical diagnosis, safety are really leading, in my opinion. There are so many other applications that we come across. We have had clients for fraud detection, and transactional paperwork is actually one of the most known topics, and there are lots of projects running in that. Just browsing through. I think safety, healthcare monitoring, and marketing are very important as well.
We have gotten requests in healthcare. I would say that's probably number 1. Trying to think where else. I mean, we haven't recently been involved with any self-driving vehicles, but in the past we've done a number of projects related to self-driving trucks as well as self-driving cars.
Nice.
And we have a question, and I don't know if this is the right time for it to be answered, but I'll share it. Not a panelist, an attendee asks, how can we use this in virtual reality and augmented reality?
That's actually a wonderful question, because virtual reality and augmented reality, in a way, is just a stream. It's a moving pictures, actually. Any movie, any picture individually can be interpreted, can be analyzed. There are so many areas that virtual reality can be used. For instance, in simulations, in training, training of pilots has been done in VR. Training of surgeons actually has been done VR. There's so many other different, in real estate, people are using virtual reality nowadays. There's so many areas where you would like to take your client or a person into a 3D constructed world. And if you like to simulate that environment, I think virtual reality and computer vision techniques are best options nowadays. And we do have the computing power for that, luckily. I hope that answers your question.
Thank you, Boulat.
That was great. Any other, because we see.
There's another question.
Great.
There's a question: in an infrastructure company, how do you convert paperwork to digital?
I think these were the answers that we have discussed in the first 2 webinars.
Yes, and that's what I was going to say.
But we can go briefly. So you can go ahead. See if
No,
you
I,
want.
I was just going to say that we did put a link in this chat to where you can find the first two webinars and listen to them.
Yeah, and at the end of this, or tomorrow morning, I'll send out the links to the previous
Yeah.
webinars
We will do that.
so that you can look at them. And I'll also attach the slides from the first two webinars, so folks can look at the slides and then they can view at their leisure.
Yeah, in short, OCR, computer vision, deep learning, and machine learning are the ways for digitizing paperwork.
Well, this is great feedback. Thanks everyone for participating. I understand this is a little tricky, and try to put a good sample, but there's obviously many other applications. As we can see, other place in the chat window to share is 14th. So I'm continue to enter those into the chat window. If we're missing anything, we should try to address those. But with that, interest of time, we'll just move on. Again, thank you so much for your participation. Fantastic feedback. See?
Oh, absolutely. I was just putting something in the chat. Sorry. Responding to someone.
Yeah.
So just to review, I mentioned earlier, for us to figure out, do you have a good, solid AI problem? We go through the following process. We first say, is it feasible in terms of the algorithms that we know are out there? And that's where we use someone like Boulant, because when you work with a senior PhD person, they will already immediately be able to tell you which algorithms to try in a given situation. And that saves time and money. So you figure out, okay, it doesn't mean you're going to use the algorithm as is. Most of the time, you're going to have to customize it quite a bit, but that's fine. You can do that pretty easily. So are there algorithms? Number one. Okay. The number two, and really should be always thought of as number one, is data. Do you have enough data? Can you get enough data? I always like to explain to people that 80% of your success in your AI challenge is going to be your data. Meaning if you've got good data, the rest of this will be easy. So we work an awful lot of time with people preparing data, even before we begin, let's say, the AI component. Sometimes 6 months before the data is ready to be used. And it does go problem by problem. Third, will this have a big enough impact? In other words, will it really impact your return on investment? And that's something we talk about with clients. And, because it takes time and effort to do this. And we don't want to undertake something that isn't going to have enough of a positive impact for the investment that you're making. And typically AI problems are ones that recur over and over, because the key to great success with these challenges is getting new data all the time and then having your algorithms be constantly updated. So, or your answers are being updated, not so much the models, but what you put in new data, you get better and better results. Jim, which problem would you want to go over today?
I think we have all of these covered.
Okay.
So we'll touch on all of them because of the feedback. It sounds like we have a cross section. So we'll just touch on any of these. If somebody wants a particular area more in detail, please enter it in the chat. The safety seemed to be the number one overall in reading surveys and so forth of the applications. Anything from cross streets, pedestrians, to manufacturing, warehouse, or energy and oil and gas, and those environments. We'll be covering those a little bit. We'll have some images in a few slides. The next two slides are more about the history of where we've seen it being used quite successfully. So in the medical area, in has been used since the beginning of artificial intelligence and expert systems, since the expert system called ELIZA, and quite a number of helping doctors make decisions, never to replace a doctor, but to help them make decisions. And now those types of algorithms are a mainstay in helping in MRIs and in different medical situations of analyzing the vast amounts of data. As you can see, all the images that they're looking at, they're trained, these folks are trained to look at these images and decipher them. Now with pattern recognition, what you're seeing is the computers helping them even more than they had in the past. So the medical field is looking very good as far as taking on artificial intelligence, and will continue to do so in the future.
We've got a couple new questions that maybe one of you want to take. Okay. One person is asking, making a comment really about real-time data and how to do analysis, I guess, of real-time data.
So yeah, real-time data is the challenge. That requires a digital twin of your data. I'm not sure what the question is, though.
Well, I think they were trying to, maybe they were just commenting in VR and AR. The comment was that real-time data and analysis are key.
Yes. And we're going to talk more about that when you're taking large volumes of data, and Bill could probably explain this better than I can, but when you're taking the huge amount of data that's required in a video can sometimes tax the computer system, even though the computers are getting smaller and smaller every year, but it's still a challenge. So we're going to discuss alternatives to that, and how can we provide not diagnosis, but create decisions with less data
Right.
that you would need with an image or a video, because of the huge files that we always create with this.
Yeah, somebody else asked when we were talking about recurrence, what about the frontier between automation and AI? I mean, we've moved in that direction. I mean, I always say automation, when you start with RPA and automating things, you're getting ready for AI.
That's right. Yeah, you need to do the process mining,
right?
The EIM, enterprise information management. You need to make sure that your data is good and clean to launch a program where you're doing sophisticated artificial intelligence, but you don't have a data master program. Is probably you're going to run out of gas very soon if you don't build that infrastructure.
I think contextual AI is going to be very important in the future. Many of the systems that we are having and deploying nowadays are not context aware, and that is going to be the next step for AI and automation.
Okay, just a couple more, and then we should move forward. We have, let's see, here's another one. How do we apply AI in the IoT world?
Well, IoT is just a device embedded with some logic, just gathering information from its surrounding. It can be a little sensor in your car, it can be your little camera, or it can be anything. So it's just an information gathering device. AI is just a general umbrella of all these techniques, extracting information from the information collected. So whether it comes from an IoT, or it's just coming from a camera, or it's just coming from a text, it does not matter for AI. The AI is just, as we tried to put at the beginning of the discussion, is a collection of these algorithms trying to find the set of rules that is so difficult for us, or repetitive, or it takes too much time. But other than that, it's just nothing but ordinary algorithms with new paradigm. I hope that
Yeah.
answers your question.
Okay. In a typical wireless network where processing is required, what is the challenge? Somebody asked. And they also asked, how difficult is it to process the data in a wireless environment?
That's more of a systems issue.
Yeah, that's not.
And it's the processing of the data is not the challenge. The challenge is interference of the wireless in a industrial environment, and RTLS, real-time location systems, are becoming more prevalent. They're getting stronger signals to be able to uh, to perform those tasks. The challenge here is that we're relying on the cloud. So if you're relying on the cloud to make a decision, you need to send it to the cloud to make a decision and feed back into the environment. What we'll see in the next 5 years is being able to make the decisions at the location of the device and then sending packets of information sporadically. So that's going to be the big change in IoT in helping all of this. So better systems to send information to the cloud, and then smaller chips, so to speak, to make better decisions at the source using AI code. So I think we should probably move on. So I'll give this one to Bulat. Great questions, by the way. You're getting ahead of us a little bit. We're going to cover some of these topics again.
That's right.
So Bulat,
Trying to read. I'm here. Thank you.
Jim, there's what the same person was asking, do the sensors talk to each other?
They can, and it's actually the aim, because you would like to make informed decisions on one sensor without being referring to the main system all the time, and you would like to have all that. And that actually brings us to this slide, and we can talk about this, because object tracking, object localization, and object classification, these three items were the driving force for any computer vision program at the beginning. And obviously there are so many different variations, but now we are not really only limited with autonomous vehicles or detecting an object, a car, because now we can talk about smart infrastructure like traffic signs, having sensors, and they can be talking with your car. One car is looking around and just detecting a pedestrian would be wonderful, but it does probably very little if your car is not able to talk the car behind you, because you're braking and the car behind you need to understand that you're braking, and so on. So that actually is a wealth of information, so many different areas. When I just looked at it, I was able to spot like at least 15 active research topics currently being published every year, dozens of articles on sorry, not particles. When we just simply go over that, like we come across road user detection, abnormal event detection, vehicle re-identification. That's just one of the very active areas, and vehicle counting, obviously. Emotion recognition is just very popular, especially emotion recognition in humans as well as animals. And carried object detection and all these kind of things, they all go back to the original ideas of object classification, object detection, tracking, and localization. We have so many different applications that are also based on these techniques.
Bulat,
Yes.
Finish, and then I have a question that will lead into the next thing you're doing.
I think that is pretty much it. These three items revolutionized everything in terms of object detection, because you can take this object localization classification ideas to facial recognition, object recognition, monitoring the medical state of people, or even medical intake of people. Medical surgeries can be actually followed through these ideas, because cavity area tracking, for instance, is one of the very important things during surgeries. Thermographic imaging in healthcare is just one of the other things. These are all just going back to these three fundamental ideas of object detection on the whole. Go ahead, please.
One person is asking, when applying video recognition to identify consumer habits, how can we ensure consumer protection? And I thought that was a good lead-in to what's coming.
Yeah, this is, go ahead.
We can start early, but we can just give you some ideas. There are a couple of things. First of all, don't use images or don't record images, or use technology that makes it impossible to use facial recognition algorithms. There are several approaches. It's just a business decision, obviously. If you still would like to track the people without invading their privacy, there are solutions. You can just go for low resolution in the optical spectrum, or you can simply switch the spectrum and go to infrared solutions. That is actually one of the examples that we are going to be discussing today. And here we see something. I think I just hand over to Jim, and we'll continue.
Go ahead, Bulat. You go ahead. Thank you.
Well, that's fine. But yes, the idea here is, again, using low resolution imaging in public areas. You would like to figure out the crowd, you would like to figure out how many people are there, or you would like to monitor, let's say, an emergency room if anyone is on the floor, fainted, something is happening, if there's any abnormality, and all these kind of things. At the same time, nobody likes to be watched with full resolution and facial recognition and all that. There are certain solutions to this, obviously. You can just use low resolution, but that's still a little bit annoying for many people, and because of the privacy rules and such, you don't want to do that. The other thing is you can say, I am using high resolution cameras, but I am not recording. I'm not really saving it on any disk. Well, in that, the user must have faith in you. That's another challenge. Or the third thing is you simply come up with technology that simply does not allow you to use facial recognition algorithms. These are thermal cameras, for instance, or very low resolution, but high sensitive thermal cameras, or infrared imaging. So infrared imaging must not be taken as night vision cameras, because night vision cameras are not thermal imagers. They are simply using very close infrared leak of the optical spectrum. So they are basically optical cameras. Moving forward, we have some other examples.
Yeah, so the other examples here are on safety. So we've discussed a little bit about, your pick and class. Of course, the pick and pack warehouses is exploding. The number of warehouses, it can't even get enough workers out there today. So this area it will be exploding in the near future. And then you're in the manufacturing environment, whether you're making cookies or you're making automobiles. Of course, these are areas where safety, repetitive motion, these types of, are we operating in the right manner? One of our partners, DuPont Sustainability Solutions, they work in this space to help from a safety perspective. And then if you're in a power plant, my old world, whether you're doing maintenance or in a shutdown, these are all environments where we can start using, as Bulat said, maybe some infrared to track, to make sure that people are moving are having the movements that we expect them to have versus not expect them to have. There's many, many different applications. So I'll just turn this over to Bulat, and we'll just talk.
There was one question that you might want to answer first.
Sure.
The comment was, there's no standardization in sensors. Should we have a standard architecture?
Probably not. And depending on what you would like to extract, what kind of information you would like to get, you unfortunately need to use a different approach. This is not because of lack of, or just it's a problem of manufacturers or anything. It's just because of the nature of the spectrum. Because electromagnetic spectrum, as you are aware, we can see like 400 to 700 nanometers, which is basically where the sun is irradiating, and our eyes are adapted to this one. Obviously, this does not mean that there are no other light beyond, so below and above that, as we know, ultraviolet and infrared. But every single phenomena in the universe, even if you're looking for the explosion of a star or a birth of a star or just any other phenomenon that is originating from the heat or just magnetic fields, they are simply carrying some certain signature in some certain wavelength. This is the way the nature is, and that is why we can detect heat in the infrared, we can see our bones in the X-rays, and so on. So unfortunately, there is not going to be any standardization in that, in this sense. There are, however, very good things happening because the infrared cameras, for instance, or X-ray cameras are really well advanced nowadays. This does not mean that one manufacturer's device or sensor matches the other one. There are going to be some incompatibilities as well. But what we do as a pragmatic solution is, for any given problem, we define the signature of the phenomenon that we can trace. Let's say we are tracing the humidity in agriculture. That actually brings us back to this slide over here. We can simply use some portion of the infrared imaging for landscaping, for agriculture, for city planning, and as well as topographical purposes and crops. If, however, you would like to go for security, then you don't really need to use the same wavelength, because now you're really looking for the thermal imagers in a hospital environment, in a gym or shopping centers, or if you like to track people, then you would like to have a camera that is sensitive to the body temperature of humans. So depending on the need, we need to change the sensors. There is some sort of incompatibility in that. We acknowledge that, but this is the way universe is. And depending on the problem we are trying to solve, we need to simply customize the solution. I hope that gives you an answer.
So we have 5 minutes left. So we want to get to the video. This is a very important
Yeah,
video.
let's get to the video. Yeah.
Go ahead.
Okay. So this is a video showing actually on the left and on the right-hand side the same thing. On the left-hand side, we are seeing an infrared image that is taken by the Polytechnique Montreal for the purpose of pedestrian detection database in their laboratory, LITIV. And we have actually developed an algorithm to detect people and monitor people on this using the techniques that we have mentioned in this webinar. So the algorithm belongs to us, and the purpose of this was just monitoring people for all other applications that we have mentioned. So on the right-hand side, what we see is the same image, but we are just seeing the silhouettes of people. We do not even see the details on the left-hand side image, but you can see that the left-hand side video is sensitive to heat. Right-hand side, we just see the silhouette, the circles and rectangles. If you look at those gray lines over there, they are simply telling us whether a person is standing, moving, and if obviously a person is lying on the ground, we can figure that by simply looking at the orientation of these geometrical extractions that we get. This actually somehow answers the question of privacy, because without invading the privacy of people, it is possible to track the people without really getting all that private information. We can use these technologies to help people. It could be in an emergency room, it could be any place, any workplace that we have mentioned, warehouses, or any other places that we have talked.
It's also a lot cheaper.
Okay, yeah, that is actually a very interesting thing, because infrared cameras are really cheap nowadays, and you can have hundreds of them deployed in one emergency room, for instance, or in any manufacturing place. And they can, interestingly, talk to each other, because you can make them talk to each other by using very simple platforms like Raspberry Pi or Jetson Nanos and such. and you can process all that information that you gather in place, in premise, but at the same time, you can simply use cloud solutions to process those images and information, whatever you would like to extract. Here is just a little list of what we can do with infrared solutions, or in general, computer vision solutions. Well, in infrared, you can simply solve that privacy issues. You don't really have to invade people's privacy just for the sake of helping them. This is like this cookie idea. The problem with these kind of solutions is actually the requirement of the multiple discipline expertise, because you need to have the AI expertise, you need to have the infrastructure, you need to have cheap cameras, and you need to have the understanding of the wavelength and spectrum and so on. The other thing is, obviously infrared can be useful is nighttime, dark places, or some other places. It is not possible to use optical cameras at all. Underwater, for instance, optical cameras are almost useless. This doesn't mean that infrared is better underwater. Underwater, usually sonar is a better solution. But depending on where you are and depending on the environment, the camera system can be changed. But the idea, the machine learning and deep learning ideas, and in general AI at the back, is always the same. So due to these reasons, many of the places, in workplaces and hospitals and such, we're not using these technologies. But now cameras are cheaper, AI is accessible, and it is possible to deploy these kind of solutions in any place.
Couple of comments and questions. Somebody asked, do we need a special coding for CCTV application?
Well, in this particular case, we would need to really deploy these AI and machine learning algorithms operating behind in order to extract the information. To gather information, actually no special coding is necessary most of the time. Off-the-shelf imaging software, so even with little Python scripts, help you gathering information. But it's not only the gathering information. Processing that information and extracting information is the most important and challenging part.
Yeah. One of our attendees comments that this is a great application for monitoring the safety of isolated employees who have to be protected. And that's one of the ones we constantly refer to. Yeah.
Absolutely.
That is correct. Yes.
Jim, you want to, what should we say? Should we take it another 10 minutes? It's 2.
Yeah, if people are willing to hang on, we'll keep going. We want to cover at least this slide, and then we can continue taking questions as long as there are questions out there. It is the top of the hour, and we do appreciate everybody's time and respect that. This is recorded, so you can view it again at your leisure when we send it out. So, Bulent, you want to close us out?
One other thing is these cameras can be fixed cameras in any workplace, but this does not have to be so. We can simply put these cameras on board to drones or ships and airplanes or anything that flies, anything that moves, vehicles, and we can just make them mobile, and we can actually use them for so many different purposes. Pedestrian detection is just one of the driving force, as I just said before. During nighttime, especially if you have an infrared camera on your car, or obviously in connection with other sensors, that could really enhance the security. Closed environments, emergency rooms, where you would like to monitor patients, are really places that you would like to use this technology without invading their privacy. Obviously, where you would like to see people, and in the opposite case, where you do not want to see people for security purposes, right, you can deploy these ideas and cameras.
Someone else makes a comment that it's great for monitoring cues, which it is. Yeah.
Correct. And there's another question: what are the tools used in AI? The tools, if I understand the question correctly, we are looking for pattern recognition. if you like to figure out the behavior of people, how they behave, for instance, in a retail store or in a given, in an airport or wherever you want, or in school if you want. Pattern recognition is just one of the things that we use, and that actually requires machine learning algorithms, and machine learning in that sense, clustering and classification and those kind of algorithms usually used. There are also several other usage of this one, because once you get the idea about some certain features in a given place, you can actually go back in time and compare that. What happened last year? What was the situation yesterday? If you have a retail store, how crowded was that last week or last Christmas? All this kind of information can be harvested. The only thing here, what infrared and computer vision in general provides us, is gathering that information, and the rest is going to be standard techniques of machine learning and AI. I hope that answers your question.
They're also asking, are there any hardware specific tools?
Trying to understand that question properly.
Well, I don't see any more specifics, but maybe they mean what kinds of computers. In other words, we're processing huge amounts of data. So we're usually using GPUs, right? But there's not anything more specific than that.
For training, we need GPUs, but for inference purposes, actually, GPUs are not needed. These algorithms, once trained, they can run on low resource devices. They can actually run on your cell phone.
Okay. The person is saying, are there any specific tools needed for OCR and signature recognition?
There are so many different tools for OCR and signature recognition, correct? For OCR, we have talked in the first two webinars, actually. OCR inherently a computer vision algorithm, but OCR itself, off the shelf, is not able to solve all your problems. It is just providing you the recognition of that letters one by one and just putting all these together to make words, and then afterwards lines. But if you like to make the meaning of those words and lines and paragraphs, then you still need to augment your OCR with machine learning algorithms.
But not hardware. They were asking, were there any hardware specific tools?
I do not recall any hardware specific tools, but if there is any, they should be employing some sort of an AI algorithm. Because we are not like in the times of AI or machine learning that we simply do solve these problems using mechanical devices anymore. All of them requires some sort of an embedded chip, and even in that embedded chip, you need to have an algorithm. NVIDIA has actually so powerful chips that you can simply go in that direction if you like to develop an algorithm and embed in an IoT. And signature recognition, just very shortly, it's a deep learning and computer vision application.
And one other question, maybe, Jim, do you want to take this? Someone asks, as the cost of sensors and algorithms are getting cheaper, what is the challenging area besides good data?
Besides good data?
Yeah, I mean, to me, that's
good data is all where it's at.
Yeah,
Building that infrastructure, building your digital twin, building out your data, and don't allow yourself to go into a silo where you're in one part of the company, you only are building your infrastructure and you don't build it for the rest of the company. So that's the danger I've seen, is we get a high return on investment in a particular area. Let's say it's transactional, order to cash. So we spend a lot of time and effort there, but we don't think about leveraging it in procurement, engineering, where there's tons and tons of data that is very disparate, and we're one-dimensional in the infrastructure that we've set up for a company. So just remember that your company is an enterprise, and try to think about as much as you can from an enterprise perspective. But when you're doing your pilots, of course, you want to show your return on investment, but take that return on investment that you earn from that and invest it into the company. Just don't take the money and run, because this is a journey. This is not going to be, the data issue will take years and years. If you're just starting, it's, I hate to say it, but it's going to take a good 5 years to get all your data under control. In 2 years, you'll think you have it all. Then you realize that you're not collecting any of the data that you need to make decisions. And so this is a trade-off between making relevant decisions off the data that you are now collecting, and then collecting more data
Right.
to help you. It's a balancing act.
And it's
that
a
needs to be,
process. That's what
aligned to your vision of your company. So that prioritization has to continually be looked at.
well,
If
what
I may
go ahead, Bulan.
add one point on that, if you have good data, that's actually the first requirement. If you have good data and if you have the infrastructure, you need a very good data science team. That is the most important problem that you're going to be facing with a data science team that understands the physics underlying of your problem, finding the appropriate solution and deploying it. That requires more than one person.
Someone is asking, can we use, well, I guess, what technique do we use to determine in a reliable way the number of people in a stadium or on a street?
This has been done actually. You use the gates if you want, and you simply place cameras, and this is called people counting. And the other technique that you can use, I think you can borrow that idea. This is how we count stars. It is impractical to count the number of stars in the universe, but what we do is we simply take samples from different parts, different portions representative of the sky, and we just make representative statistics. That is a very reliable technique, actually. If you like to have an order of magnitude, very good approximation, you can simply deploy some cameras inside the stadium or just in a street, and you can just go for the number statistics. And actually, this is a very, very active research area, and you can get very reliable results. The alternative is find some bottlenecks where you can really count people with high accuracy using, for instance, infrared. Infrared is wonderful because it is very easy to subtract the background because it is only sensitive to heat. And you can figure out whether that's an animal or a human, a child or an elderly. You can just get all this information, but you don't get any private information like facial landmarks and all this. I think I would go with infrared any day.
Okay. Any other people have comments about what constraints you're encountering?
Yeah, so these constraints are unfortunately very common.
Yeah.
The CapEx, getting the return on investment, the technical competence, what Bulat mentioned, having the right data, having the right expertise in house from a data, a AI perspective, and then building those ROI case studies with the stakeholders. So it's always a partnership between the business and the AI scientists to tell the story, and coming up with those use case studies that are practical and realistic to bring value, sustainable value versus short-term value. That needs to be looked at so that you don't end up building something that is going to be circumvented very soon. So it's a true coordination. It's a change management discussion also. So don't forget about that, when you're doing this is going to be a shock to everybody. Everybody's going to be worried about their jobs when you say you're doing an AI project, when of course the goal is to help people in their jobs, but you're going to get resistance. So be ready for all of those types of situations. You really need a change manager, a change leader. You need business buy-in. You need your AI scientists. You need data. It's a lot to bring in all together. That might be a topic for next webinar. We can talk about all the different players that are required to make an AI journey work.
The other comment or question was, is 5G useful in this process, or what, does it fit in at all?
It may, if you're just going to be sending things over internet, but it's distantly related. If
Yeah.
you're having anything processed on premise or in just low resource devices, there is no need for really high speeds if it's going to be an intra-cluster operation. If it's going to be on the cloud, obviously speed is going to be good, but the servers are not really affected once you get all that information. If you're working on real-time data, yes, speed and speed and amount of data you can shuffle is going to be crucial, of course. Anytime it helps.
Right. And somebody else comments, is this good for remote surveillance? Yeah.
Absolutely.
Yeah.
Yes. Absolutely.
Yeah, that's one of
Well,
our
it's
case
been
studies.
great. Thank you, everybody. You've had wonderful questions.
Yeah, fantastic feedback.
Well, as usual, we conclude with this slide. We love this, and we love the idea of Occam's razor. We are not very sure whether that hypothetical philosopher really said this, whether he lived or not. But the idea is choose the simplest solution possible and don't clutter your solutions with unnecessary details. And that's very important, and it's one of the pillars of modern science, so to say. And obviously, video infrared augmented with machine learning and artificial intelligence is really a solid solution for many of the problems that we have mentioned in this video, and many of them we did not have time to go over. But most importantly, it is cheap, it is accessible, it is doable, and it solves the privacy problem very neatly and brilliantly. Thank you very much for all of you attending and asking these wonderful questions.
And we will pick up again. You'll all be invited to the next, let's call it round 2, because obviously this is a very robust topic and it can't be answered all in one session.
Yes. So with that, I'll just close it out. As C mentioned, we will be having another webinar because as we put this webinar together, we realized that we need to have at least one more webinar on this topic. And just to let you know, on May 11th, we'll continue our supply chain risk and resiliency series with operational propensity. Then we'll also be in new product introduction and speed and resiliency. By the way, if you're looking for digital applications in the new product introduction area, we do have a webinar devoted to that under new product introduction. So applying digital techniques there. And of course, we'll continue this series starting on June 22nd for the next webinar. We do have a lot of the questions here were about digital twins. We will be having a digital twin demonstration on May 25th. That should be very interesting from a manufacturing perspective, which aligns to a number of the questions that were asked. And then we'll talk about hyper automating your business, which also came up in today's discussion with NVIDIA's. And then we'll be also talking about, let's get back to basics with operational excellence with Mike Gamba. And then how do we link the ERPs with the digital twin, which is a very exciting webinar coming up very soon. That's an integration between our ERP partner, VAI, and Creatisoft. So that's a very interesting webinar coming up in June. So we look forward to seeing you there. Again, we are focused on people, process, data, and technology. Of course, we spoke about technology today, and this is our over 40 companies in our group. And again, thank you for joining us. Bulon and C, any closing words, comments?
Thank you very much for your time and your patience listening all this. I hope it was useful for anyone, we would be more than happy if it just helps someone tiny bit.
Yes, I mean, we look forward to continuing this series. We are getting a better idea of what people are interested in, and we'll keep going because we want people to realize that AI is a practical solution to everyday business problems. And I think it's been put on a pedestal in a way that people don't realize the practicality of it. And I'm not saying it's simple, but it's doable and it is practical. So we look forward to having you join our next event. You'll all be invited and get many emails.
Yes, we'll get many. Thank you again, everyone. Thank you, Blunt. Thank you, Steve. Thank you all for so many incredibly insightful questions for us. You really got us thinking. Thank you so much. We really appreciate you taking time out of your busy day. And we'll, again, post the video and the slides very shortly. Thank you and have a great